everybody, this is Miss Bufford, and in this video we're going to talk about fusion versus fission. So your learning goals for this video are to be able to compare fission reactions and fusion reactions. And the first one we're going to talk about is nuclear fission. So this is the process in which one atomic nucleus splits into two smaller atomic nuclei. This can be induced by firing neutrons at a large nucleus, and it usually occurs with larger nuclei more readily because they have, that their size makes them somewhat unstable. And remember, in that previous video, we talked about the fact that anything with an atomic number larger than 83 is going to be naturally radioactive. And so it tends to be the larger nuclei that undergo nuclear fission. This occurs as a chain reaction, and so that's what this picture that I have here is showing. You'll notice that we're starting over here with uranium-236, and that's breaking up into barium and krypton. And then when this reaction occurs, there are 3 neutrons released. And then those neutrons can then hit other uranium atoms, and those uranium atoms will split and form other elements. They'll split into smaller elements. So here we've got xenon, strontium, rubidium, and cesium. And then when these nuclei right here split, they also release neutrons. And those neutrons will hit other uranium atoms and then cause those uranium atoms to split. And the process just goes on. So you can see how it's a chain reaction that occurs until the neutrons that are released don't hit any more uranium atoms. Some examples of where nuclear fission is used is in atomic bombs and nuclear reactors for power generation. So nuclear fission, it does produce a tremendous amount of energy, but it does not produce as much energy as nuclear fusion produces. And so nuclear fusion is the process in which 2 smaller atomic nuclei combine into one larger atomic nucleus. So here, instead of splitting something into 2 smaller things, we're taking those 2 smaller things and we're putting them together to make a larger nuclei or nucleus. And so this generally occurs between smaller nuclei more readily. And in order for this to continue, it needs to have a source of hydrogen as fuel. And this, like we said just a minute ago, produces more energy than fission does. And so let's take a look at our example over here. So I've got a helium nucleus right here and a second helium nucleus right here. And these arrows are showing that they're coming together and they're smashing together and they're forming a beryllium atom. All right, and then beryllium here can then fuse with another helium atom or helium nuclei, and they'll form carbon when they come together. All right, and then the hydrogen source comes in, when we smash 2 hydrogen atoms together, we get, helium nucleus. And so hydrogen forms these helium nuclei that then can smash together and continue to smash with larger and larger nuclei until we end up with some, atoms as large as iron or nickel. All right. And some examples of where we can see nuclear fusion taking place would be in hydrogen bombs. So this is similar to the atomic bomb, only it's using nuclear fusion instead of nuclear fission, and in stars. And so if you notice, the only way that humans are able to use nuclear fusion currently is in a bomb. So we don't have the ability to harness this power just yet. We don't have the technology or possess the technology required to be able to control a fusion reaction enough to be able to make it useful for anything other than use in a hydrogen bomb. But there are people studying this and working on ways that we may one day be able to use fusion reactions to produce energy. Nuclear fission reactions like we talked about on this slide right here, are used in nuclear reactors for power generation. So this is a clean source of energy. As long as, it's being handled and maintained appropriately, it can be a really good source of clean energy. But then again, like I said, you have to maintain them. And the nuclear reactors we have these days are a lot better than a lot of the nuclear reactors that we've had problems with in the past. All right, so here's just a Venn diagram to kind of show you the differences, to compare and contrast the two types of reactions. This would be a good thing to include in your notes. And if you have any questions about nuclear fusion or nuclear fission, you're always welcome to write them down and ask during class. Thank you for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.